Imagine journeying to the center of the Earth, past the crust, the thin shell we call home, deeper through the mantle, a sea of molten rock. Finally, you reach the core, a place of unimaginable heat and pressure. Unimaginable because we can never truly reach it. This isn't the realm of Jules Verne. No, this is a place of science, of mystery. Why, after 4.5 billion years, is Earth's core still so hot? What fuels this fiery heart within our planet? The answer lies in a story of cosmic collisions, radioactive elements, and a relentless dance of heat and rock. It all began with chaos. Imagine a young solar system, a swirling cloud of gas and dust. Out of this chaos, Earth was born. Pieces of space debris, drawn together by gravity, collided in a fiery symphony. Imagine the heat generated by these impacts, the immense energy released as our planet coalesced. This, my friends, is the primal heat, the energy from Earth's formation trapped deep within its core. But that's only part of the story. This primal heat is constantly replenished by the slow, relentless decay of radioactive elements and the dance of the mantle, a slow churning that shapes our world. Picture the early Earth, a swirling mass of molten rock and dust. Gravity, the great sculptor, pulled this material together. Each collision released unimaginable energy, heat, more intense than any volcano we know. The young Earth glowed with an infernal light. This wasn't just the birth of a planet, it was the birth of a star that failed. A star that, instead of igniting into a nuclear furnace, cooled and contracted. But this cooling was a slow, drawn-out affair. Like a dying ember, the young Earth held onto its heat, trapped beneath a growing crust. As Earth cooled, something extraordinary happened. Heavy elements like iron and nickel sank towards the center. This wasn't a gentle settling. Imagine a rain of molten iron cascading down through a sea of magma. The friction generated was immense, adding yet more heat to the core. This iron rain created the Earth's core. A solid iron heart, 2/3 the size of our moon, surrounded by a liquid outer core. This liquid iron, constantly churning, generates a magnetic field, a shield protecting us from the deadly radiation of space. The formation of the core was a defining moment. It created an engine within the Earth, a source of constant heat and energy. The pressure at the core is unimaginable, millions of times greater than at the surface. This pressure, combined with the leftover heat of formation, keeps the iron in a constant state of flux. But the core is not isolated. Heat from this internal engine rises, driving the movement of the mantle. This slow, churning dance of molten rock shapes the very face of our planet, creating continents, mountains, and the very ground we stand on. The Earth's heart still beats with the fiery energy of its birth. Billions of years ago, those collisions, those grand impacts, forged our planet in a crucible of unimaginable heat. That heat didn't simply vanish. It became a prisoner, trapped beneath a thickening crust. Think of it like embers in a fire pit. Long after the flames die down, the embers glow, radiating heat long into the night. The Earth's core is like those embers, still radiating the heat of its violent formation. This primal heat is a fading echo of creation, but it's not the only source fueling the Earth's internal furnace. Deep within the Earth's core, a different kind of fire burns. It's not a fire of flames and combustion, but a fire of decay. Radioactive elements, remnants of the universe's earliest stars, lie buried within the Earth. Uranium, thorium, potassium. These elements are slowly decaying, atom by atom. Each decay releases a tiny burst of energy like a microscopic spark. But there are trillions upon trillions of these atoms, and their collective decay generates a significant amount of heat. It's a slow, steady burn, a nuclear reactor at the heart of our planet, constantly replenishing the heat lost from Earth's fiery birth. The mantle's embrace. Imagine a pot of water simmering on a stove. Heat rises, creating currents that circulate the water. The Earth's mantle behaves similarly. Heated from below, the mantle churns in slow convection. This drives tectonic plates, causing earthquakes and volcanoes. The heart of the matter. Deep within the Earth, pressure reigns supreme. Imagine the weight of the entire world pressing down on a single point. That's the reality of the Earth's core. Under immense pressure, iron behaves in strange ways. At the Earth's surface, iron melts at 1,538 degrees Celsius. But deep within the core, iron remains solid, locked in a crystalline structure. This solid inner core, a sphere of iron, spins within a sea of liquid iron. Section 2. A legacy of stars. The iron itself holds a secret, a clue to the core's enduring heat. Within this iron are traces of other elements, remnants of ancient stars. These aren't the elements we see in our everyday lives. These are heavy elements, forged in the hearts of dying stars, scattered across the cosmos in supernova explosions. Uranium, thorium, potassium. These elements found their way to Earth during its formation, seeds of stellar death embedded within our planet's core. They are ticking clocks, each atom a tiny time bomb, set to explode in a process called radioactive decay. Section 3. The unseen clock. Radioactive decay is a silent, unseen process. An atom of uranium, unstable and restless, suddenly transforms. It sheds particles, shedding energy along the way. This energy, released as heat, is the lifeblood of the Earth's internal furnace. Think of it as a slow, controlled burn. Unlike the rapid combustion of a fire, radioactive decay unfolds over eons. Each atom decays at its own pace, following a rhythm set by the laws of physics. It's a clockwork universe, ticking away deep within our planet, a constant source of heat that has kept the Earth's core molten for billions of years. Section 1. The rise and fall. Imagine a lava lamp, its colorful blobs rising and falling in a mesmerizing dance. This is a simple analogy for a much grander, slower dance happening within the Earth's mantle. Heated from below by the core, the rock of the mantle behaves like a thick, viscous fluid, slowly churning in massive convection currents. Picture this. Near the core, superheated rock, lighter and less dense, slowly rises towards the surface. It carries with it the heat of the Earth's interior, a silent, invisible plume. As it rises, it cools, becoming denser, and eventually, like a weary traveler, it begins its long descent back towards the fiery depths. Section 2. Sculpting Earth's face. This slow, relentless churn is more than just a conveyor belt of heat. It's a sculptor, an artist shaping the very face of our planet. Continents tear apart, creating rift valleys and new ocean basins. Cool, dense rock descends, forming deep ocean trenches and fueling volcanoes. The Earth's surface is a jigsaw puzzle in slow motion. Continents drift, collide, and grind, driven by mantle convection. Mountain ranges like the Himalayas are born from these collisions. Section 3. The unseen hand. Mantle convection regulates the Earth's internal temperature. It acts as a cooling system, transferring heat from the core to the surface. Without it, Earth would be a furnace, uninhabitable. Tectonic plates, driven by mantle convection, create and destroy. They shape our mountains, valleys, and coastlines, but they also trigger earthquakes and volcanic eruptions. Section 4. A delicate balance. The Earth's core, the mantle, and the crust are locked in a delicate balance, a dance of heat, pressure, and motion that has played out over billions of years. The core, with its enduring heat, drives the convection currents in the mantle, shaping the Earth's surface. The mantle, in turn, helps to regulate the core's temperature, preventing our planet from overheating. This delicate balance, this intricate interplay of forces, is a testament to the complexity and wonder of our planet. It's a reminder that we live on a dynamic, ever-changing world, shaped by forces that operate on a timescale far grander than human comprehension. Section 1. Mysteries of the Deep. For all our scientific instruments, for all our deep probes and intricate models, the Earth's core remains a place of profound mystery. It's a realm hidden from our direct gaze, a place of immense pressures and temperatures where even the most resilient materials surrender to the unimaginable forces at play. We can simulate these conditions in laboratories, recreating the crushing pressures and searing heat for fleeting moments. But these experiments offer only a glimpse, a tantalizing hint at the true nature of our planet's heart. The core holds on to its secrets tightly, challenging us to unravel them. We still don't know exactly how the core formed. What was the precise sequence of events that led to the creation of this solid iron heart, surrounded by its churning liquid shell? How did the lighter elements, the remnants of ancient stars, become trapped within this iron embrace? And what about the dynamics of the core? How does the solid inner core interact with the liquid outer core? What role does this interaction play in generating Earth's magnetic field, our shield against the harsh radiation of space? These questions linger unanswered, fueling the fires of scientific inquiry. Scientists probe the depths of our planet using every tool at their disposal. Seismic waves travel through Earth's interior, altered by the materials they encounter. Analyzing these waves creates images of Earth's inner structure, like shadowy X-rays. New missions plan to send probes closer to the core than ever before. The study of the Earth's core is more than just an academic pursuit. It has profound implications for our understanding of the planet's past, present, and future. The core's heat drives plate tectonics, shaping continents, forming mountains, and triggering earthquakes and volcanoes. The magnetic field, generated by the liquid outer core, protects our atmosphere from solar wind radiation. The Earth's core, a place of immense power and mystery, remains a searing inferno billions of years after the planet's formation. The echoes of that primordial fire and the ceaseless churn of the mantle all contribute to this enduring heat. Our planet is a dynamic system driven by forces far grander than our fleeting lifespans. The Earth's heart still beats, a fiery pulse that sustains life on our planet. The core remains a place of wonder, a testament to the enduring power and mystery of the universe.